Hi everyone, thanks for attending my talk today. I'm Dennis and I will be giving you a presentation about creating a serverless architecture using Java and Quarkus. I'll quickly go over the content of my talk. First, a small introduction of myself, my company, and the product. Then I'll showcase you the application that I developed, and for I'm going to show you how the architecture looks like and which AWS serverless components are used. Afterwards, it's time for a more technical demo, where I'll be showing you the difference between a Lambda function written in Java and one compiled as a native image by using the Quarkus framework. And to end with, I'll briefly inform you what's still upcoming and what the future of the application can bring. So, like I mentioned, I'm Dennis Baerten. I'm a Java developer for about 15 years now and living in Belgium. I'm the owner of Ennovative Solutions. This is a private company held for my freelance activities and it was launched in 2013. Since working as a freelancer, most of the times you do a project where you get paid by the hour and you're kind of limited to the amount of hours you can work in a day, so I was looking for a longer time already to launch a product for myself. So in 2020 I launched Baerten, which is a digital showroom assistant. For this, I'm the software engineer, I'm the sales manager, doing the marketing and so on, basically trying to do everything myself. So let's kick off with the application we're going to use as a reference during this presentation. I'll first quickly guide you through the features of the application in order to get some context when we go over the architecture. The first and most important part is the mobile application, which is the digital showroom assistant. The app is used by the salesperson who is guiding you through the store and trying to sell products. The idea behind the app is that it's a complete catalog of what is in store, but also what can be ordered. Another aspect of the app is the visualizer. The first type of clients we are targeting are the ones that are selling tiles or floors, so the visualizer can replace the floor based on a single tile and some predefined scenes. This allows you to show different colors next to each other and all different kinds of interiors, so that the customer get a better view and understanding of what he wants to purchase. Then I'll quickly go over the features that are available in the dashboard and the management application that you will see later in the architectural diagram. It all starts with the dashboard where you get some in-store analytics. This tells the store owner which types of products or which products are viewed a lot. In case of stores where we have multiple salespersons, we can also view how well they perform and how many appointments are actually converted into an order. Time for some technical details in the architecture. So first I want to explain what is serverless and why go for that approach. Well, the definition is added on the slide and it's coming from the Cloud Native Computing Foundation. The short answer is that the developer, the person who deals with the business logic, does not need to be concerned with the server. The service provider handles it. In this case, it's AWS. So why did I choose for this serverless approach? Well, basically because I didn't want to manage an EC2 instance myself or deploy the application as a container on a Kubernetes cluster. I would need to keep them up to date and apply security patches and so on. I just wanted to focus on the real implementation of the application, so just my code and some YAML files, of course, to set up the components. Next to the simplicity of serverless, you also have the main benefit that you only pay for what you use, which makes it even a more better candidate than starting something new. It's of course not always the case. If you, for example, have an application that would always get the same amount of load or throughput, you might be better off with an application that's always running. The following diagram shows the complete architecture of how the application is set up right now. So for the front-end applications, the entry point is CloudFront, which is a CDN in front of S3, which serves the assets, and JavaScript for the applications. Those are built with React. Next to that, there is an API gateway in front of the Lambda Functions, which routes a request back to the serverless implementation, which in this case is a certain Lambda function. For authentication, we're making use of Amazon Cognito. This one is linked to certain parts of the API gateway. By linking it like this to the API gateway directly, we don't need to add any authentication logic anymore inside our application. Our business logic is split per domain, and the Lambda functions are also set up like that. If there is need for a Lambda function to save or persist other data, I've chosen to create an S3 bucket or a DynamoDB table per function. This separation makes it easier to create something new or even divest when something is not needed anymore. Of course, I also looked how easy it was to deploy, and then it makes more sense to create and deploy those resources together. And for your information, I'm using the serverless framework to deploy those via Circle CI. For the appointment parts, it's not only using a DynamoDB table for saving data. So I'll zoom in on this part. There's a DynamoDB table, but there's also a stream link to that table. Via this stream, we are capturing the changes made to an appointment, which is adding and removing products. That data is then processed asynchronously and is feeding our summary data, which is used on the management dashboard. For now, the summary DynamoDB table looks sufficient. Maybe in the future, I'll probably rewrite it to something more flexible like Elasticsearch. Our appointments Lambda function also puts messages on SQS queues when the status changes. On that SQS queue, we also have another Lambda function which is triggered by those events, and it will send out notifications to the customer via email. And for that, I'm using SES, which is the simple email service from AWS. So before we dive into the demo, let's go a bit more into detail of the Lambda functions that contain all the business logic. So what is a Lambda function? AWS Lambda is a serverless compute service that runs your code in response to events and automatically manages compute resources for you. So if you remember the drawing from the previous slide, those events come from an API gateway, SQS, a stream, or different other kinds of events. The code behind a Lambda function can be in several programming languages, such as Python, Node.js, Java, Go, C#, and several others. I'm not going to discuss in this talk which programming language is the best for using in a Lambda function, but as a full-time Java developer, for me the option to use Java was obvious. This was one of the main drivers next to the fact that the product should be finished and launched as soon as possible. In theory, it looks all very promising to have AWS Lambda start their function whenever an event is triggered. But there are some side notes to be aware of. The lifecycle of a Lambda function consists out of an initialization part, invocation part, and a shutdown phase. Let's start with that initialization part first, where AWS will bootstrap their function. And these starts can either be a cold start or a warm start. A cold start occurs when AWS creates a new instance of a Lambda function to process events. This can be when a new version of something is deployed or when a Lambda function is inactive for a longer time. The cold start is most easily observed by an increased latency to process an event in comparison to a warm invocation of a Lambda function. If you have an application used in production by a lot of customers and your load is quite equal, most of the time you won't even suffer too much from those cold starts. However, when you launch a new application with only a handful of customers, the cold start is a problem, or at least annoying. Definitely if you have a Lambda function per domain which results in multiple cold starts when the user browses through the application. So for the ones that are also doing development or using Java, you are probably aware when writing a Java application, it first starts up the JVM which actually runs our code. The startup of that JVM is what's causing the cold start of the Lambda function to be slow. There is now a solution to this problem of the JVM which needs to start, being a native image created by GraalVM, which actually converts your application into a native image. At this moment, there are several Java frameworks out there that support you with this. We have Micronaut, Spring Cloud Function, and Quarkus. This one is the framework of my choice. Quarkus, in contrast to the other frameworks, is engineered to boot up quickly and uses less memory. It is therefore well suited to use with Java, with Lambda. Even more important is the fact that it is designed to work seamlessly with GraalVM so that if desired, you can build your app as a native executable, but also in JVM mode. So how does Quarkus do this? It tries to do as much during build or compile time instead of at runtime. There is a challenge, however, when trying to run your Java application as a native binary. You cannot use all libraries and tools you want. There is stuff like reflection, method handles, and so on. But because GraalVM tries to do a lot of optimizations, such as removing dead code, it will analyze your application, and if you don't use a field method constructor, it will remove it. That's why reflection does not work out of the box. There is of course a way to support for this, but it's up to you as a developer then to make some configuration changes or annotate some classes. I'll come back on this during the demo. So to start the demo, I'll go to code.quarkus.io, which is your starting place when creating a new application with Quarkus, and where you can select which frameworks you want to use in combination with Lambda. So let's search for AWS, and it will select Amazon AWS Lambda and DynamoDB, and we generate our application. This results in the following project. So here I cheated a little bit and already prepped some code. So I made one Lambda function. I'll go over it. And it implements a request handler. And for the sake of this demo, I'll just use an API gateway event. So there is a get, which will retrieve all registrations, and a post to save registrations. And if you do something else, it will throw an error. I'll go first to saving a registration. So what I get, I'll parse the body from the request with JSON to a registration. Then I'll use a DynamoDB client, and I'll save it into a table, and then the response will be a 200 with nothing in the body. And for a get, we'll have the same. We have to retrieve all registrations. It will do a scan of the complete table, convert our DynamoDB items into a registration, and I'll respond that as JSON. Now, the main model is pretty easy. It looks like this. It's just an event and a name. And that's basically it for the code part. And if you generate the code, it will give you some YAML files to use SAM local. But for this demo, I will use serverless as well, since I'm used to that for my application. And to compare JVM mode and native mode, I made two separate serverless files. I'll quickly go over them. So the service name, I will use the domain manager, which is used to expose the Lambda function behind an API gateway. My package, so Quarkus will generate the zip file for me called function zip. I prepared one for JVM mode and one in native mode. And then you can see here, which is the handler that will execute your code. So in JVM mode, this is the Quarkus tree handler, which will find the class needs to perform the request. And you see it's running in Java 11. Then if we go into native mode, it all looks the same, except that there are handler, it doesn't even matter. So I just take handler, and the runtime is provided, because in the native image, it doesn't matter. There's no runtime. It's all baked into the binary image. So what I first do is create an Uber jar. So that's basically a fat jar that contains the code and all the libraries needed to run. It will take about 20 seconds or so to build this zip file. And that's the one I'm going to deploy to AWS. It's just my account. And then we'll execute the curl, and then you can see the cold start and warm start. So I have some curl commands ready here to execute. Just take a simple one where I'll fetch all the data. I'll first deploy it. So right now, normally you just have one serverless file, but I made a different one for JVM mode and Lambda. And native mode. Deploy this one. And that's the great thing about serverless. It can create all kinds of resources for you, and just with one deploy command. And that's why I combined DynamoDB and the Lambda function and the API gateway all together. There we go. So now it's deployed. So I'll do a curl, and I'll print the time to this. And right now the Lambda's starting up and querying DynamoDB, and as you can see, to return those 3 events, it took 6 seconds, which is really slow. So I'll do the request again, then you can see it takes 3 milliseconds, so this is a warm start. So I'm going to create a native image now for this Lambda function. So I'm using this gradle command. where you can see that the package type is native, and I'm saying use a container build. So what it will do is use a Docker container to actually build this Lambda function as a native binary. I already executed this command, so this one. And there you can see that it takes quite a long time to generate a simple Lambda function. So in this case, it took about 4 minutes. There are a lot of reasons. That's because of the code optimization that GraalVM is trying to do, and trying to see which code is really necessary. So it will try to search all the access paths and remove the code that's not necessary. So this one I'll deploy now as well. What I'm going to do now is also deploy this one, and I'm using my serverless native YAML file. And then in the meantime, grab my curl command, and I'll do the same like before, and just fetch all the registrations for a specific event, and then you can see how long it takes with a native image in cold start and a warm start. So deploying it right now. There we go. So the native image is deployed now. I'll execute the same curl command. Okay, voila. There you can see it's showing cold start. Instead of the 6 seconds like before, it's now only 700 milliseconds. A warm start, even less. So we gain a lot of performance by using the native mode in combination with GraalVM, which is supported by Quarkus. That's it for the demo part. So to wrap up, since we only recently launched the application last year in the middle of the pandemic where stores were closed, the main focus now lies on getting our product adopted into the market by some more stores. There are still lots of technical possibilities left in the retail space that can be added to the product, such as augmented reality, planning of appointments, better customer follow-up, and other automation features. Thanks for watching my presentation, and hopefully you will also give it a try to combine Java with the Quarkus framework when you're creating new Lambda functions.
Right, and so I'm also joined on the feed, of course, by Dennis. Where are you joining us from, Dennis, today?
Hi Tom, I'm from Belgium, so literally a small city in Belgium.
Gotcha. Belgium is one of the places that I miss visiting as a result of the pandemic. There were a lot of DevOps and infrastructure as code and other related things going on there through the year, and I used to take the opportunity to go and visit Ghent and visit Bruges and hang out with the beers and the fries over there. It's a shame not to be able to be there at the moment.
All the good things.
Absolutely. So. Quarkus, tell me, is this specifically what Quarkus is for, or does it do something else normally and you've repurposed it? What's the story behind it as a framework?
Oh, it's focused on the native image thing, but there are a lot of other things in it. So they're also focusing on running your applications on Kubernetes with as less resources as possible and so on. So it's more or less like a competitor to Spring, but it's also compatible with it.
Gotcha. So anywhere that I might be running a Java workload in a container or as a Lambda, it's probably useful for that.
Correct. You can use Quarkus for that.
Gotcha.
Use all the benefits with other frameworks.
Sorry, go on.
Yeah, it's rather new. It's officially from Red Hat, and it's even supported right now. So.
Right. Gotcha. The compile time of the Quarkus version of your Lambda was pretty high, right? It was sort of 4 minutes or so. Is that because it's also compiling the dependent libraries and all of the other things that you like the Lambda libraries and the DynamoDB libraries and those things?
Yeah, well, it does. It will try to figure out everything that it needs for running, and that's why it's taking so long. So I think it's trying to follow the execution path of your application and strip out all those things. It really takes a long time. It's one of the downsides of it. So you only have to do it before deploying it.
Yeah. And does it have the ability to cache some of that for subsequent compiles, or is that the cycle time for everything?
No, not yet. It has been requested a few times. I'm in the Zulit chat as well, so where all the Quarkus developers are, and it has come to mind a few times already, but it's not in there yet.
Right. Yeah, it seems like, I guess if you're developing your code for sort of functionality, maybe you don't use that, and then you kind of use the Quarkus approach in the final compile before you push out into production.
Yeah, correct. That's why I have the two serverless files. So I can run it in JVM mode, and then it takes only a couple of seconds to build it. Then I can test it locally and also deploy that version before we go to a test environment or production. I make the native image.
Yeah, and you mentioned that there are some things that it's unable to work with, so things like reflection and so forth. Does that mean that there are some types of software, maybe some libraries that you'd use that will never work, or is it the case that you can make anything work? It just might take a bit more effort to tune something that is using reflection in more detail.
Yeah. So what the Quarkus will try to do, they are creating some extensions, so which is their version of the library, and then they work around those things that don't work. There are some libraries that are not suitable for doing that. And reflection is one of those things, but you can work around, and I think it's in the code. You can register one of the classes, so to say, I'm using reflection for this, and then the parts, when creating native image, it will take that into account. So there are workarounds for it, but not everything will work. Uh,
So if
that's the
you
downside. It's rather new, all this stuff.
Right, so you might find that you bring in a library and it's all working in your test environment, but actually it's not going to work in production, and you can't convince it to either, which I guess would mean then that you have a slow Lambda for that particular bit of functionality.
Right. Yeah.
Yeah, gotcha. Um, are there any other sort of limitations to I guess the reflection is one of them. Are there any other sort of key Java things that people would recognize where you say actually Quarkus doesn't work with that?
I think that's the most, reflection is the one that's used most. So what you do is you take in your body, you parse it with JSON and whatever. So I think that's most of the times the error you stumble upon is the reflection part. There are some other technical things, but I didn't come across those.
Yeah, gotcha. Let's talk a bit more sort of generally about your AWS landscape. I think you said you were using the serverless framework for deployment. Was that right?
Yeah.
How do you find that to use? Did you try some of the alternatives? What led you to choose serverless as a thing to use for that deployment?
Yeah, I was already using serverless for one of the clients where I'm working on projects for, and I found it really easy to just take all the resources you need. Behind the scenes, it's using CloudFormation, so it all works together. So if you see my serverless files for the SIA appointment, for example, it contains a DynamoDB, it contains SQS, and it all just do LS deploy, and it's all working. It's pretty easy.
Mm-hmm. Good. And what's what are the things that AWS doesn't do for you that you'd like it to do? Like what's on your shopping list for reInvent later on in the year? What are you hoping to see?
That's a tough. For a moment, I'm using the basic functionalities, and yeah, I get there. So nothing really that I'm waiting for at this moment. No.
Mm-hmm. I think you mentioned you're using Cognito. Is that right?
Yeah.
I remember earlier on in the feed I was complaining about Cognito. Have you come across any limitations with that service that you've bumped up against in your development?
Not really. I'm using it really basic. So the user management and so on, it's not integrated that much into the application. It's only in there for the authentication part. So no integration with other things like Active Directory or so on. So it's really basic, but yeah, it works, and it keeps the authentication logic out of my application.
Yeah. Sorry, excuse me. Been a long day. And what are the next steps for the application that you're building? Where are you planning on taking this?
Yeah, I mentioned, so I was mainly focusing on the technical parts of the application, and I should focus on the other stuff as well. So first sales and trying to get more customers for the application. If that's the case, then I would like to focus on what the data I'm collecting. I think I can do a lot more with that. So this, so instead of just capturing all the data, I think there's more into like getting upfront what the customer will need or what other products are of interest for the end consumer.
Mm-hmm. So very sort of early days in startup land for you in that product.
Yeah, correct.
Yeah. Good. I mean, it's exciting times at that stage in a business. I think where you're figuring out what works and what you can where you're going to go next. It's a fun time.
This moment just an MVP phase. I have one customer already, and I'm trying to search for people who are going to help me with the sales and the marketing stuff.
Gotcha. Good. And was I right in saying this is the first talk you've given at an event or a meetup?
Yeah, indeed. I'm trying to do some talks at a customer, for example, but that's only for a small audience. And you know the people. It's also a difference.
Yeah, pretty nerve-wracking, but good to flex those muscles. I think for me, public speaking was a fundamental part to building my career, I think. So it's good to see you taking a step on that journey, and good to see you doing that with us.
Thanks.
Good stuff. Congratulations. So thanks for joining us, Dennis. Been good to chat with you. Thanks for sharing your experience of Quarkus, and I'll let you post in the stream chat if your contact details if people want to follow up and maybe help you with the sales and marketing of your application.
Would be nice.
Great. Thanks very much.